Welcome to the deep dive. You know the challenge, right? Trying to keep every single requirement, every test, every change in a big software project perfectly aligned.
Yeah, exactly. Information just gets scattered everywhere.
It does. Traceability becomes this huge task, and suddenly, well, you're drowning in documents that just don't talk to each other.
And, lots of application lifecycle management systems, ALM systems, they promise to fix this, but often they just add their own complexity.
Right.
So today, we're going to cut through that noise. We're diving into Almirah. It's a framework that aims to bring some order to that chaos, using an approach that, honestly, might surprise you.
Okay, I'm intrigued. So our mission today is basically to give you a shortcut to understanding Almirah. We'll look at its core parts, its unique take on traceability, and how it guides you through the whole software development lifecycle.
Exactly. And we're drawing this from a few key sources today. There's the main Almirah Framework overview, but also details on its Ruby gem, its architecture and resources, plus specific docs like the software requirements specification, the SRS, and the system specification, SYS.
Got it. A solid stack of info.
Yeah, and the goal is really to show how Almirah tries to simplify all that project requirements, test, and change management stuff. And it does it using some surprisingly simple but pretty powerful ideas.
Okay, so let's start high level. Almirah is pitched as this comprehensive ALM framework. It promises, quote, streamlined processes and software components. Sounds good, but like you said, lots of systems promise that.
Yeah.
What's the foundational idea here? What makes Almirah different?
Well, it really boils down to its core philosophy. And something we found pretty quickly in the sources is that Almirah uses this modular kind of plug-in approach.
Yeah.
So you can pick and choose the bits you need. But here's the real kicker, the thing that stood out. The framework defines simple text files in markdown format.
Markdown.
Like the stuff used for read-MD files.
Exactly that markdown. Placed right into your source control tool, let's Git. And that becomes the single source of truth for basically all your specifications, requirements, architecture, design, everything.
Wow.
And it doesn't stop there. It extends to your test cases, your test scenarios, your protocols. They're all marked down too, living alongside your code.
Markdown files is the bedrock for ALM. That genuinely is surprising. I mean, you usually think of complex databases or, specific proprietary tools for this level of control. So if everything lives in plain text markdown, what does that actually unlock for a team? What's the benefit?
Well, think about it. This isn't just some quirky technical detail. It's actually a pretty profound shift. Suddenly you're free from vendor lock-in, right?
Right.
No more wrestling with complex, opaque document formats or hidden databases. Your entire project's critical information lives in human-readable plain text.
Which means you can version control it just like code. Exactly. Version control, diffing, branching, merging, all the stuff developers love doing with code, you can now do with your requirements and test cases. The auditability is just built in. Traditional ALM systems often struggle to offer that without huge overhead.
Okay, that makes sense.
And it leads directly to what Almirah calls a needs-based adoption model. You don't have to swallow the whole system at once.
Ah, so you can ramp up. How does that work in practice?
Yeah.
Like step by step?
Yeah, you can start really simple. Maybe just begin with your requirement specs in Markdown. Use the Almirah Ruby gem, we'll get to that, just for basic traceability between them.
Okay.
Then maybe next you add your test specifications, also in Markdown. Again, use the gem, this time to check your test coverage against the requirements.
Still pretty straightforward.
Totally.
No.
Then, if you need stronger version control and history, well, just put those Markdown files into a Git repository or whatever you use. Set up a review process, use branches for different product versions or features, tags for baselines, standard stuff.
Right, using existing source control workflows.
Exactly. And then say you need to meet certain quality standards, like for audits. You integrate a standard task or issue tracking tool like Jira or whatever with your repository. That gives you the transparency you need. So it scales up really nicely.
Okay, this sounds practical, but the obvious question is, how do you actually do this? If it's all markdown files and source control, what's the tool that pulls it all together and makes it work?
Good question. That's precisely the role of the Almirah Ruby gem. It's the engine, really. It processes all those markdown files.
And getting started with it, is it complex?
Surprisingly simple, according to the docs. First, installation is just gem install Almirah. One small thing to note. They emphasize using the capital A in Almirah. Apparently that's essential.
Okay, gem install Almirah with a capital A. Got it.
Then, to see how it works, you can create a simple example project using Almirah create your project name. That command sets up the basic folder structure for you.
All right, so you have the gem, you have a project structure. You write your specs in Markdown.
Yeah.
Then what? How does the plain text become, linked and reportable?
That's the magic of the please command. Almirah, please, your project name.
Please, seriously.
Yeah, please. Its main job is handling the traceability, connecting your specifications to each other and connecting specs to test cases. When you run it, it chews through your Markdown files, converts them to HTML.
Okay.
And here's the cool part. It automatically replaces all those internal references you put in the Markdown with actual clickable hyperlinks in the HTML output.
Okay. So it builds the web of links.
Exactly. And it also generates those crucial traceability and coverage matrices reports showing what's linked to what and what requirements are covered by which tests.
What about running tests? How does that fit in?
Right. So your test cases start out as protocols in a test protocols folder. They're just markdown files describing the test steps, but they aren't marked as executed yet. To simulate a test run, you copy the relevant protocols into a specific run folder, like test run 001 for run number 1. Then you edit those copied markdown files to mark each step as pass or fail.
You literally just type pass or fail in the Markdown.
Pretty much, yeah, according to the docs. Then you run the command again, but tell it which run you want to process. Almirah, please, your project name, run 001.
And that gives you...
That generates a coverage matrix specifically for that test run 001. It shows you exactly which requirements were covered in that run and whether the corresponding tests passed or failed.
Wow. Okay, the idea that one simple command, Almirah, please, can take your raw Markdown, turn it into a fully linked HTML report with all the traceability and coverage info, pulling straight from version control, that's genuinely powerful. It really does sound like a shortcut to getting a clear picture of your project's health.
It really does. And of course, for this to work smoothly, the gem expects a certain holder layout. Nothing too crazy, but you'll typically have a specifications directory for all your requirements, design docs, etc.
Makes sense.
And then you'll have test protocols for those base non-executed test cases and test runs for the copies you actually mark pass-fail in. Keeping that structure is key for the gem to find everything.
Okay, got it. Structure matters.
Yeah.
So let's zoom out a bit then. We've talked about the Markdown, the gem, but how does Almirah map this onto the actual day-to-day work of developing software? What's its perspective on the bigger application lifecycle, from idea to release?
Right, good question. Almirah is definitely designed to support that whole lifecycle. The docs lay out a pretty comprehensive process structured around several high-level stages. Think software release planning, then software design, implementation, testing, and finally the release process itself.
Okay, standard phases. How does it handle the first one, release planning?
So in software release planning, the idea is you start with your high-level requirements, or HLRs. These then get refined and broken down into what they call work breakdown structure items, or WBS items.
Like tasks or user stories.
Exactly, things you can actually track. These WBS items become the basis for tracking all the planned activities. The roles here might be, say, a project manager kicking things off, with managers and team leads responsible for getting those HLRs into version control, as Markdown, of course, and creating the WBS in your tracking tool.
Okay, so planning sets the stage. What about the design phase? How do those HLRs become detailed specs within Almirah?
In the software design stage, those HLRs evolve into more detailed specifications. This could be your actual software requirements spec, functional requirements, non-functional architecture docs, system specs, detailed design, you name it.
A lot of potential documents.
Yeah, and WBS items are still used here to track the scope of transforming, say, an HLR into a detailed spec. All these specifications need to be created again as Markdown and version control, then reviewed and formally approved.
And the critical part here must be traceability again, right? How do you link an HLR to the detailed spec that came from it? Or link different design docs together?
Absolutely key. Almirah defines 3 core types of traceability links here, and interestingly, it leverages the tools you're likely already using.
Okay, how does that work? How do you connect, say, a requirement spec to the task that created it?
So for linking a specification to a work item, X2WI, which shows which spec paragraph is being worked on by a specific task, the idea is you'd actually mention the specs ID, maybe even a paragraph ID like SPID 001, directly in the description field of the task in your task issue tracking software.
So you put the link in the JIRA ticket or whatever.
Exactly. And that's often supported by a workflow in the tracking tool, like draft, may scope review, sec scope approved.
Okay, what about the other way around? linking the task back to the specific document version it produced.
That's work item to specification, WI2S. This identifies the exact output. And here, Almirah relies on your source control commit messages. The commit message should reference the WBS item ID.
Makes sense.
And then your task issue tracking software can, in turn, reference the specific commit ID. So you have a two-way link using standard tool features.
Clever. Leveraging commit messages and task descriptions. And what about linking specs directly to each other? Like, this requirement depends on that architecture decision.
That's specification to specification, S2S. This shows those logical connections, the design flow, and this is where those markdown extensions we mentioned earlier really shine.
This PID things.
Yep. You put a unique paragraph ID tag, like SPID001, at the start of a paragraph you want to reference. Then elsewhere, maybe in another document entirely, you refer back to it using a reference tag at the end of a sentence, like SPID001.
Okay.
And when you run Almirah, please, the Ruby gem spots these tags, understands the connection, and turns SPID001 into a clickable hyperlink in the HTML output, pointing directly to the paragraph tagged with SPID001.
Ah, so the links are actually in the markdown made live by the gem. That's neat.
Right.
Okay, so that covers design. What happens when we move to actually writing code, the implementation phase?
Right, software implementation. Here, your detailed specifications are transformed into actual source code. And again, WBS items track the scope of this work.
Traceability is still important here, I assume?
Crucial. You still use S2WI for defining the scope, which requirement is this code fulfilling. But you also introduce work item to code, WI2C. Similar to WI2S, this identifies the exact source code produced by a WBS item.
And managed the same way. Commit messages and task links.
Exactly the same principle. Commit messages reference the task ID. The task references the commit ID. It ensures every chunk of code can be traced back to a specific task and through that task back to the requirement or specification it implements.
Okay, solid traceability from requirement to code. Now, what about testing? That's always a big piece of the ALM puzzle.
Definitely. Software testing in Almirah is broken into two main activities: test design and test execution.
Makes sense.
In test design, you're creating your test cases again as markdown files based on your detailed specifications. In test execution, you run those test cases against the actual software build and mark the results pass or fail in the markdown run files we talked about.
And traceability for tests. How do you link tests back to requirements or tasks?
Two key types here as well. First, there's work item to test cases, WI2T. This links a specific task, like design tests for feature X or execute tests for feature X, to the actual test case files created or run. Handled just like WI2S and WI2C, using commit messages and task tracker references.
Okay, linking tasks to test files.
And then, maybe more importantly, there's specification to test case, S2T. This is what shows your test coverage. It defines which specific part of a specification is verified by which test case, or even which test step.
How does that work in the markdown?
It uses specific rules again. Your test case ID usually comes from the markdown file name itself, like tc001.md. Inside that file, you'll often have a table defining the test steps. Within that table, for each step, you can include a reference tag like SPID001 pointing to the exact specification paragraph that step is testing.
Ah, so you link individual test steps back to spec paragraphs.
Yes. And you also mark the pass-fail result for that step in the table in your run file. When Almirah Please processes this, it creates hyperlinks from the spec paragraph to the test case and step that covers it, and vice versa. Makes checking coverage super easy in the HTML output.
That's very granular.
Yeah.
Okay, so after planning, design, coding, testing, what about the actual release?
The final stage they describe is software release closure. This is where you bundle up all the planned artifacts for release, the source code, the compiled binaries, all the approved specifications as markdown, and the final test cases and results.
A complete package.
Right.
Okay.
This stage usually involves specific types of WBS items to track the release activities, and it requires some supporting services, obviously, for storing the final artifacts, but also, importantly, for export.
Export, what needs exporting?
Well, for formal documentation, you often can't just hand over raw markdown files. So the process involves taking the final approved markdown documents from source control and converting them into a standard text processor format, like Microsoft Word or LibreOffice Writer.
How do you do that?
They mention needing a tool, a markdown files converter, to handle that conversion. Once it's in a text processor format, it can go through final review, maybe get formatted nicely with headers and footers, and then finally get exported as a PDF for official sign-off and archival.
Okay, so there's a path to formal PDF output too. That's important for many organizations.
Right.
Wow, it really is a comprehensive journey they've mapped out, isn't it? From the initial idea right through to the final PDF release.
It is.
And the way Almirah provides the tools and defines the processes seems designed to make sure nothing falls through the cracks. Plus, the breakdown of roles and the emphasis on review stages really seems to enforce accountability. That's often a struggle in big projects.
Absolutely. And if you connect this back to the bigger picture, Almirah isn't just that Ruby gem. It's really presented as an ecosystem. It's a set of processes designed to work with standard software components you probably already have.
Right, you mentioned needing certain tools. Can you recap those? What are the essential components?
Sure. At the core, you absolutely need source control. Git is the obvious example, but anything that can store code in Markdown, handle commits, branches, tags, that's fundamental.
Right, source control check.
Then you need code review software. Something that lets you review changes not just to code, but also to the Markdown files and the commit messages themselves, because those commit messages carry traceability information. Tools like Jarrett or features within GitHub or GitLab often cover this.
Right, review capabilities.
For actually creating the content, you need editors, a Markdown editor for the specs and tests, and a source code editor for the code. These days, they're often combined in one integrated development environment, or IDE.
Standard developer tools. What else?
Then you need those document tools we just talked about. A Markdown files converter to get from Markdown to a format like .docx or .odt, and then a text processor like Word or LibreOffice for final formatting and exporting to PDF.
Got it. Converter and text processor for formal docs.
And finally, for the project management side, you need task issue tracking software. Jira, Redmine, Trello, whatever. The key requirement is that it needs to be configurable enough to support the specific WBS item types. Almirah suggests like document task, code task, test design task, test execution task, and allow you to define custom states and workflows for reviews and approvals.
So it integrates with standard tools, but you need to configure them appropriately.
Precisely. It's about leveraging what's common, but setting it up to support the Almirah process.
And the Almirah Ruby gem itself.
Right.
Just to be crystal clear, what are its specific jobs again? What does it do under the hood?
Okay, yeah, the gem is the linchpin. Its critical functions are.
It converts your Markdown specs and test cases into that interactive HTML output.
Right, the HTML generation.
2, it parses and processes those special Markdown extensions, the SPID, paragraph IDs, and the SPID references, and crucially, turns them into active hyperlinks in the HTML.
Building the traceability web.
3, it recognizes those test step tags within Markdown tables, understands the SPID DACT, links there, and integrates test coverage information directly into the traceability views.
Linking tests to specs.
4, it generates those various traceability matrices we talked about, spec to spec, one-to-one and one-to-all views, and spec to test case coverage matrices.
The reports.
5, it provides these reports primarily in HTML, but the docs mention it can optionally output them as CSV too, which could be useful for importing into other tools.
Okay, flexible output.
6, and this is important for quality. It actively indicates if there's a link pointing to an item that doesn't actually exist. So it helps you catch broken references, dangling links. That's a key error checking feature.
Oh, that is useful, like a linker for documentation.
Kind of, yeah.
Yeah.
And finally, 7, it provides useful statistics in its output, things like the total number of controlled items, like paragraphs or test cases, how many have uplinks, how many have downlinks, how many have test coverage, whether there are any duplicated IDs, and what the last used ID number was, which helps in assigning new ones.
So the gem is basically the brain processing all the Markdown and generating the intelligent linked output. But what does this actually feel like for you, the user? How does this translate into a practical, intuitive experience when you're faced with potentially hundreds or thousands of these linked documents?
That's where the user interface features, primarily driven by that HTML output from the gem, really come into play. The goal is to make navigating this web of information incredibly easy and save you a ton of time compared to manual digging.
How so?
Okay, so for any given item in the HTML, say, the specific requirement paragraph, it shows you uplinks. These are the IDs of other items that this paragraph references using those SPID tags. These IDs are shown as clickable hyperlinks.
So you can immediately jump to what it depends on.
Exactly. And if an item links to multiple other items, the UI is smart about it. Initially, it might just show the number of links, like 3 links.
Yeah.
If you click on that number, it expands into a list of the individual clickable links. Keeps the initial view cleaner. Clicking any link takes you straight to that external item.
Nice. What about seeing what refers back to this item?
That's covered by downlinks. Similar idea. It shows the IDs of other items that reference the item you're currently looking at. Again, they're clickable hyperlinks, and they use the same expand collapse mechanism if there are multiple downlinks, so you can instantly see the impact of changing this item.
Okay, up and down traceability, instantly navigable. What about test coverage?
That's handled by coverage links. For a requirement paragraph, this section shows the IDs of the test cases and even the specific test steps within those cases that are marked as verifying this paragraph, using those SPID tags in the test step definitions.
And these are clickable too.
Absolutely. Same clickable and expand functionality. Clicking a coverage link takes you directly to that specific test case, likely highlighting the relevant step. Imagine how much time this saves compared to manually searching through test plans or reports to confirm coverage. It makes exploring this complex documentation genuinely interactive and efficient.
Yeah, that instant navigation, being able to jump from requirement to code commit to test case to related requirement, all through hyperlinks, that's a massive win for understanding and for audits.
Hmm.
And underpinning all of this, as you mentioned earlier, Almirah also defines a pretty clear set of roles to make sure everyone knows their part. Document manager, various types of reviewers, developers, authors, team leads, test engineers. It really does seem like a well thought out, orchestrated system.
It does paint a picture of a very structured process, yes.
So wrapping things up, what we've really unpacked today is how Almirah presents this, well, fascinating approach to application lifecycle management. It really leans into simple markdown files powered by that clever Ruby gem to build a highly traceable framework.
Yeah, the emphasis is definitely on making connections visible and processes clear.
It feels like it genuinely tries to simplify complex project management by explicitly linking everything from those initial high-level ideas right down to individual test results, taking it from a potential headache to something more streamlined.
And what's really interesting to me is Almirah's commitment to making all this critical information not just available, but truly discoverable and auditable. That automated traceability, the intelligent linking generated from plain text,
Yeah.
it's quite elegant.
Yeah.
And it offers this clear path for teams or organizations to potentially mature their software development processes. You can start simple, just markdown and basic traceability, and then scale up, adding source control integration, task tracking, formal reviews, the whole 9 yards, without necessarily jumping into a monolithic, overly complex tool right away.
So thinking about our listener, what does this all mean for you?
Well, whether you're a developer who's tired of documentation being out of sync, or a project manager looking for clearer oversight and easier audits, or maybe just someone curious about more efficient software practices, Almirah definitely offers a compelling example. It shows how structured processes combined with some smart, lightweight tooling can potentially turn that feeling of information overload into actionable insights. It's a really interesting case study in process and tooling, and it leaves me thinking, considering Almirah's very markdown-centric, text-based approach, how might the wider adoption of similar systems based on version-controlled plain text documentation, how might that fundamentally reshape collaboration and auditability in other fields beyond just software? What happens when things like financial reports or legal contracts or maybe even architectural blueprints can be managed, versioned, diffed, and linked with the same rigor and transparency we apply to source code? It's a provocative thought, isn't it?